Hello, I'm Mark, and welcome to part 1 of my Unreal Engine tutorial on how to build a multi-stage and non-linear questing engine for your Unreal Engine games. So in this video, we'll be setting up the basic project. We'll be doing that in Unreal Engine version 5.6. And once we've set up the project, we'll also be stubbing out the basic questlog class, and that will be using an actor component, as well as stubbing out the questing interface. We're going to need that as a dependency when we get to quest dependencies. And then finally, we'll be creating all the data structures needed to configure our quests within our questing engine. So as always, we've got a lot of ground to cover today, so let's get started. Okay, so I'm going to be using Unreal Engine 5.6. So once you fire up Unreal Engine, just come to Games, come to Third Person, and for me, I'm going to be using the C++ project. It's just how I like to do things, and it's especially useful when dealing with something as complicated as a questing engine. So I'm going to hit C++, give it a name. I'm calling mine Core Questing Live. And then hit create, and then once Unreal Engine and Visual Studio have done their thing, you should get a project that looks just like this. Alright, so let's get started on stubbing out some basic structures that we're going to need for our engine. So to do that, I'm just going to come down and in the content drawer, I'm just going to come down under C++ classes, going to come to the folder that they created for us. Mine is called Core Questing Live, and I'm just going to go ahead and right click and go to New Classes. Under here, the first thing I'm going to do is I'm actually going to create an actor component. This is going to be my quest log. And under here, I'm just going to hit Next. And I'm just going to click on the public private and make sure it says public so that we put it in the right place. And we're going to give this a class name, and I'm going to call mine Core Quest Log Component. And I'm just going to put a subfolder here called Questing. That way we know where it's going to. It'll keep it nice and separate from all of the other code that is being created in this project. I'm going to hit create class and let Unreal Engine go ahead and create me a actor component. So let's give it a little bit. There it goes. Let it compile. First compile in the morning. Alright, there it is. So if we come back under classes, now we have a public folder with a questing folder in there, and here's our component. So we'll come back to this a little bit later. And the reason why I want to create this is because I've got a dependency within the data structures for the table that's going to need this. So the next thing I'm going to do is I'm going to go ahead and create an interface as well, since there's going to be a dependency there. And so to create an Unreal Engine interface in C++, we're going to right click, go to New Classes, and we're just going to scroll down to the bottom, and then you should find this Unreal interface here. We're just going to hit Next, and again, I'm putting this under public and questing. And there we go. I'm going to call it Core Questing Interface. And I'm just going to hit Create Class. Alright. And then we're going to do one more. And this is actually going to be a class for our structures. So we've got the interface, we've got the component. So now Unreal Engine doesn't have a way of creating structs, or doesn't have a template for structs. So we're just going to have to take our empty C++ class here and convert that to a struct for us. So again, I'm just going to go ahead and select none, hit next. public questing, just make sure it's going to go in the right place for me. And I'm just going to call this one core questing row. So because this is going to be a data table, I always like to make sure my structs, which are going to be configured for tables, are going to have the suffix of row on there. So we'll just go ahead and do that. Hit create class. And all right, so that should be everything that we need to generate for this video anyway. And I'm just going to bring this up. I'm going to say reload all. And we don't need anything there, so let's just reset this up. So here's our public, here's our questing folder, so there's our interface, there's our quest log component, and then there's our row. So now we're ready to go ahead and start converting this into our questing engine. Okay, so in order to turn this core quest row into a struct, we just need to do a couple of things. So first off, I'm going to bring in some includes. So the first one is going to be our data table include, because I want this to inherit from the data table struct, so we could use it as a data table. And then I'm also going to need to add a generated.h, and we need to make sure that this is always going to be the last include in your include stack. Alright, so now that we've got that, let's go ahead and turn this into a struct. So the first off, I'm going to put a prefix there. And we'll just prefix these real quick. And I'm just going to remove this from here. And since I don't have... I'm just going to put those there, so we don't need to worry about, we'll just inline that for now. Gonna need to put a useStruct blueprint type so that this will show up in the editor. Gonna reclassify it as a struct, and since we're using the generated here, we also need to add the generate body macro right here. Alright, so that should turn everything over. Oh, and before I forget, since this is going to be a data table, let's have this thing inherit from the table row base class. Alright, so that should do everything. That should do it for converting this over. So now let's go ahead and get all of the dependent structures needed to build out our table. So let's get started. Okay, so the first thing I'm going to do is I'm going to bring in some enumerators that we're going to be using to help configure our table structures. So the first one is going to be the core questing objective type. So this is all of the types of objectives which were going to be in our stage. So as you can see here, so this is just a little enumerator, int 8. Don't need too many of these. This should cover nearly everything that you probably want in a questing engine. If there is another type, you could just go ahead and just add one to the enumerator right here. But this should cover it all. Next, because we have rules, so our objectives can be broken up into really two sets of rules. It's either three sets of rules really. It's either going to be a passing rule, a failing rule, or it's going to be a branching rule. So this is going to be telling the questing engine as it's processing the objectives on a stage how it wants to process an individual. So again, this is just a little enumerator. By default, everything's set to passing, but if you wanted to go and do failing or branching, you can. And then finally, the final enumerator, well, I don't know if it's the final enumerator, but it's the final one I've got so far. I do tend to like using enumerators. is this is our core questing classification. So we have main, faction, side, and miscellaneous. If there are other types of classifications, again, you can just add them into your enumerator. But this is just a nice way to kind of just help to just classify your quest, and that way when you bring your quests out of your quest log and putting into your UIs, you can figure out where you want to divvy them up. If you've got a more fancy UI which wants to break into main quests, faction quests, and which factions, you can do that. Just helping, using this enumerator. All right, so that should do it for all of our enumerators. So I'm just going to go ahead and minimize this for real estate. And actually, you know what? While I'm here, I'm just going to go ahead and just bring this up a little bit, make it a little bit bigger. There we go, for you guys. All right. All right, so that's the enumerators. So now we can start working on the actual data structures themselves. So the first struct I'm going to do, these are actually going to be some support system structs. So what I'm going to do is I'm actually going to put all the structures needed for the table in the file. And so, in order to help the compiler out, I'm just going to start with the support structures. Then we'll start, from the low level structures, and then we'll bring it all the way back up to the table struct here. So again, we're working from the bottom and working our way back up to the top. So the first one I'm going to create is, and I'm just going to put a note here too, and bring it all over. So the first one is going to be our, just going to bring this over for the other solution, is going to be our inventory rewards. So as part of the reward system, we want to give you you're probably going to want to give XP. Maybe you want to give gold as well, or currency. It could be gold, credits, Zen, whatever. And usually, in some quests, you get a reward, which is coming from your inventory. So the way I'm doing it is setting up, I created this little structure to help kind of manage that for us. So, and most inventory systems are on tables. So again, I'm going to be using, you're going to see this a lot, which is the data table row handle. And what this does is it allows you to point to the inventory table as well as the item on the table that you want to associate, and then you can put a quantity here. By default, the quantity is always going to be 1, but yeah, if it's like a gun or a sword, right, or a piece of armor, it's usually going to be quantity 1, but you could get half a dozen med packs as a reward. So again, and so we've got the quantity there too. So just a nice little structure, kind of keep things organized for us. So that is the questing inventory rewards. Next is going to be, as our supporting structures, I'm going to bring in the, we'll just change this over. This is our core quest reward. So this is how we define a reward. And as you can see, XP, currency, and then I've got an array of our inventory rewards here. So again, just keeping things organized and structured. And by doing this, it gives us the ability to create a reusable structure which we can push around, keeping everything together and not having to worry if things start to get separated from each other. So, organization. And then finally, our last supporting structure. This is just something that I'm putting in because I have so I can support my dialogue system. So that's my Orator dialogue system. So, and all that is just a topic ID and a starting point, and that's just how my system works. But this will allow you, if you have a dialogue system, you probably, you can then say that this quest, needs to use this dialogue, and however you want to dynamically map that within your data structures. All right, so that should be it for our supporting structures. So now we can start working on the table structures. So the first big structure that I'm going to be bringing in for our table structure or substructure is going to be our quest objective. space there. And so this is our core quest objective. So both the name and the description are going to be F texts. Then I've got the, this is the objective type, which will go to our objective type up here. And by default, I just set it to location. So that's just the default. Yeah, so once you create a new objective in the table, then you can go in and use the enumerator to tell it what it really is. And then we also have another enumerator. This is our rule set, and that's using this enumerator up here: pass, fail, and branch. And then I'm using an F name for the objective ID. So this is just a literal string that we can use, and this is how we're going to be able to map objectives back to the current objective within the questing engine that we're trying to achieve. And then this is the amount. So if it's a location, it's usually going to be a location of 1. If it's a boss, it's usually a boss. But if it's henchman, you might want to have more than 1. But by default, everything should at least be 1. If it's a time quest, then it would be seconds. It's just the amount of thing that needs to happen in order for us to meet the objective. And then I've got a little boolean check here, is optional. By default, it's false. So an optional objective would be, could be kill half a dozen henchmen while trying to kill the big boss. If you kill half a dozen henchmen before you kill the big boss, you get the objective, the optional, as well as the big boss. If you kill the big boss before you get the optional, then you don't. Yeah, and that's just how the system works. And then we have core quest rewards. So here we are, and there's our support up here for rewards. So again, this system is the way that the system works is that you can have rewards on the objective, on the struct, and on the quest, and the system will, as you're kind of walking through this and accomplishing objectives and stages, it will then aggregate that information up to give you a final score based on that. All right, so that is the core questing objectives. So next up, now that we've got our objectives, let's move over to our stage. So so these are the individual stages that can be done within a quest. And I'm going to create another little, again, another enumerator, because my stages actually have 2 types of logic sets. And this will, when we start getting in the next video, we'll get into the actual engine code for each quest, and you'll start to see kind of how we can configure each stage. It's, so that by default a stage is going to be passing and failing, but we could also set it up for branching, and it's just different logic on how we want the objectives to be used within that stage of a quest. And the quest can have multiple stages. It can either be a single stage, or it could be as complicated as having 10 steps, 10 stages to get to the end. So that's how that is set up. So now, once we've got the enumerator, let's go ahead and bring in the stage struct. And again, I'm just going to go change this API. So this is our stage. Again, generated body. So just like an objective, we've got stage name, description. These are using F texts. These are useful because you can use this for localization. So if you've got strings that you're using, and you may want to have localization later on in your game, so you may want to have one for English, one for German, one for French, one for Russian, one for Spanish, right? By using ftext, this will allow you to create localization files, and so it will then map the strings to the localization for you by using the ftext. So this is useful when dealing with localization versus just using fname or string. Again, we have here's our enumerator for pass, and by default I've set it to pass fail. but so that's the rule logic that we'll use, or the stage rule logic that we're going to be using within the stage. And then we've got an array of objectives. So there's our objectives up here. That's the array. And then we've got this. So this is for if it's a pass fail, I'm using an F name to move to the next stage. So if we meet all of our minimum required objectives for passing this stage, we'll move to this stage. Otherwise, if we hit a failing objective, at least one failing objective, then we'll move to this stage, and that will be played out in the rule logic when we get to there. And then if this is a branching, then instead of using the pass fail, we'll use this map. And I kind of left this note here. So this is the objective ID and this is the stage ID. So this is the objective that was met, and this will be the next stage that we move to. And that's kind of how that's working. Again, rewards, there's our struct up there, reuse, and then if we needed a dialogue component, there's the dialogue for this stage. And then here I've got a little helper function, which is get minimum number of passing objectives. So let's go ahead and get this going. So I'm going to say show potential fixes. And we'll go ahead and get this. So because we have the concept of optional, right? Well, optional is an optional, so we shouldn't be including the optional as part of the minimum number of objectives to pass. And so this function will be used again within the questing engine when it wants to evaluate have we met all of the objectives on a given stage. So all it is just a simple little count. We iterate through the objectives, and if the objective is not optional and it has a rule of passing, right, then we're going to count it. So this is the minimum number of quests that we need to pass in order for us to pass to the next stage. So just a little helper function. And since all the data is here, that's why I like to keep these things on the struct. Okie dokie. So that should do it for stages. So now we're moving closer to the core quest row, which is our table. And again, the final structure I want to make for our core quest row is actually going to be our dependency. It's going to be our dependency struct, and that dependency struct is actually going to require some things on both the quest core component as well as the interface. So this is where it's going to get a little bit interesting. But let's go ahead and set up the struct first before we get to the implementation. So on this core dependency struct or rule struct, we've got three more enumerators. So the first one is going to be the dependency type. Is this a quest, a player level, or a faction level? Then I've got this core quest dependency expression, so min, max, or equal. And then we also have the none, passing, and failing. So we use none when it's kind of player level or maybe a faction level, but passing and failing is only really useful when you're using a quest ID. And again, we'll get to this when we get to the implementation part of this struct within the rule set. And then finally, let's go ahead and bring in the dependency rule. I'm just going to go grab this real quick and minimize that. And so here's our core quest dependency rule. So this is how we define dependencies for whether we can do this quest or not. All right, and that will be, and usually these dependencies will be managed within the quest giver component, and that will, or whatever is giving the quest, it will then want to evaluate to determine whether it can give you this whether it's able to give you this quest or not. So really a quest dependency rule is, again, what type, that's defined by this enumerator. We've got the expression, which is defined by this enumerator, and then we've got the dependency outcome, which is defined by that enumerator. And then within this struct, I've actually got 3 functions. One public, which is the validate dependency. So this is what we'll be calling to be able to validate the actual dependency rule. And then we have some private functions. So based on which type it is, we have meets player level versus meets quest completion. So let's go ahead and just fix these real quick. All right, so I'm just going to minimize that for real estate. So here we are. These are our quest dependency functions implementation. So we're ready to start this. All right, so validate dependency. Pretty straightforward logic. This is just going to come in. We're going to put the player. We're going to be passing the actor in to the into this dependency rule, and then we'll then make the evaluation. So we're going to take a look at the type and then determine. I'm using an if statement. You could use a switch as well. It's up to you if you have more of these rules that you want to put in. But usually, if it's just 2, I'm just going to use an if statement. So I'm just going to have player level and quest ID. If you had a faction, you could add the faction in there as well. And then all it does is it figures out which function to run, and then it's going to return. And again, its return type is going to be a bool, a true/false. All right, so that should do it for the validate dependency. This is the public function, so now we have the 2 privates. So this is where it's going to get a little tricky. So before we do this, I'm actually going to come back to our interface. And let's go ahead and define this, because our dependency functions are going to be looking for this interface on the actor that's coming in. So I'm just going to go and bring these functions over from the interface, and we're going to need to bring in some and I'm also going to bring in some of the structs as components as well. So here on the core quest log component, this is just for our quest log here. And on the quest log, I'm actually going to go ahead and put the struct, now that I've got it, there. So row.h. So just adding this here just to make things a little bit easier on the interface. It's just going to do the quest log, and since the quest log component is referencing this struct, it'll just fall through for us. So on the interface, we have a reference to the quest log itself. So that's how we can find our quest log. We've got a helper function here for quester's current level. We have update player rewards, and then we have update quest objective. And we'll get into these when we go ahead and integrate and add this to both the character and the character's player controller. So I actually put this in 2 places because this, we may need access to the quest log either from the character or from the player controller within the game. So it gives us some flexibility. It's just an interface. And so the way I'm setting this up now here, and we'll see this a lot more when we start getting into actually the implementation of the questing engine, as well as the UI as well, components. So for meets level, that's pretty simple. We have a function on there which tells us what the character's level is. So I'm just going to go grab all of this and put this in. Core questing interface, so I'm going to need the interface. We don't want the generated class. Public questing. There it is. That's the one we want. Alright, so meets player. All we're going to do is we're just going to take the player, which is an actor, cast it to see if it actually has this. Then what I'm going to do is I'm going to take the value. So we're storing our value here. So here we have the rule. Here we have the expression. Here we have the outcome. These are all enumerators, but I'm storing the value as a string. And the reason why I'm storing as a string because it gives me options. It could either be a string where it's a quest ID or a stage ID or whatever. It could be an ID, but if it's a number, I can also store it as a string, and we can use the C string, which is a structure in Unreal Engine, which will allow us to get access to the A to I function. And all we do is we just pass the string in by pointer reference, and it will give us the integer. As long as it can cast it to an integer, it will then bring back the integer for us. So that's how we'll just convert it. Then I'm going to check to make sure that this is valid. So if I pass in a player that doesn't have this interface, we do not want to execute any of this logic. We only want to do it if this interface is valid. So again, expression. So because this is, I can use equal, min, and max. So if this quest says you have to have a character of level 8 and only level 8, I don't know why you do that, but yeah, you could. Then you could run the equals to versus the min or the max. So again, it's just going on the interface, getting this function here, which is the current level, and then making that equation for us. And again, it's returning a boolean, which will then return back up to the validate, and then return back to whatever it is asking to see if the character meets the, or if the character and whatever's in its quest log meets the dependency. All right, so that's for meets player level. So the other one. Okay, and then finally we have the meet quest completion. I'm going to hold off on the implementation of this only because there's actually some dependencies on the actual questing object component, and which we will be getting to in the next video. So as you can see, there's a little bit of we've got a little bit of interplay here. So what I'm going to do is I'm going to hold off on that, and again we'll come back to this function when we're ready to get into handing out quests using the quest giver. So we'll just hold off and just keep this like that for now. I don't like usually just holding off on things like this, but it kind of makes sense. Because there is just interplay between the various little subsystems, and until we get a complete system, it just doesn't make any sense for me bringing over the code only to have to comment it all out. So I'm just going to hold off on that. So let's go back to the row. So now that we've got all of our supporting structures, now we can come down to the core quest row and under table, and let's go ahead and finish this off for this video. All right, so for our row, I'm just going to go bring everything in. Real quick. So again, ftext for quest name, quest description. I've got a little tracker here. This is the tracker description if you wanted to have a tracker widget, which is showing all the quests that you're currently tracking versus non-tracking. This could be very useful when you've got games where you've got lots of quests, or active. You could have lots of active quests just to kind of make it a little bit more manageable. Again, here's our category. So again, that's referencing the enumerator up here. And by default, I just set it to main. And then here's our quest configuration. So is autocomplete, is auto accept and autocomplete. So there are 2 Boolean flags there for us to configure, can archive quest, and then can archive the failed quests. So you can see here, this is set to true, these are set to false by default. Again, this is kind of, I'm trying to figure out, this is kind of like my thinking of how a default quest would be, and then anything on top of it, you'd then go ahead and update in the table. Stages, so here's our stages, and so again, our system is going to be working more like a state machine. Our stages within the quest are kind of like states of the quest. So to do that, we're going to use a map. So we have the stage name, or stage ID, and then the actual stage itself, which is sitting there, and that's referencing back up to our stage object here. And then again, core quest dependencies. So this is our dependency model, and that's what we just did up there. So if there's any dependencies that need to be met before this quest can be handed out, that's where it is. And then again, rewards, reusing that core quest reward struct. And then finally, I've got this orator thing here. Again, this is for my dialogue setup. So we've just got this struct, again, being able to reuse it. And then I've got this little thing here, get stage orator data. So I'm just going to go ahead and just finish this off real quick. So potential fixes. And I'm just going to go, this is pretty simple. We're just going to go in here, do a find. Here's the stage ID, do a find to see if that stage is there. And if that stage is there, then we'll just bring back the information, which is just this struct. Pretty simple. This is just a nice little utility function. Again, that's why I like doing my structs in C++, since I'm coding in C++. We can create these little helper functions for our tables and just keep all that logic in one place. Alright, so that should do it for all of our tables and all of our structs. That's going to do it for this video, for part 1. In part 2, we're going to go ahead and create the quest object, and that will require a series of some more structs. You know, lo and behold, structured data. So we'll create the state structs for the quest, and we'll create the quest object, which is the actual engine for a particular quest to run in. All right, so that will do it for here for part 1. So as always, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel. If you have any questions, feel free to leave them in the comments below, and I will see you in the next video. Cheers, have a good day.